Okay, first to go through all trigonometry identities. Do you remember trig identities?
Um, vaguely. If you start listing them off, I may
Yeah.
know them. Not entirely
So
sure though.
for example, sine squared x plus cosine squared x, it's always going to be
1.
1. So secant squared minus tangent squared is always 1. Cosecant squared minus cotangent squared x, always 1. Then you learn the half angle, double angle formulas, right? Sine 2x is nothing but 2 sine x times cosine x. Do you remember those things? Cosine 2x could be written in 3 different ways. One is cosine squared x minus sine squared x. Another one is 2 times cosine squared x minus 1. So this is called a half angle formula, right? Then this is 1 minus 2 sine squared x. These are the basic identities you have to, keep in mind all the time when you do simplifications and all, right? In some part of the problem, you may come across, just a minute. So, when you do a differentiation problem in Cal 1, right? At one point, you may come across 2 sine x cosine x. If you know this identity, in place of 2 sine x cosine x, simply you will replace by sine 2x, isn't it? So whenever you see, secant squared, you could rewrite secant squared in terms of tangent squared by using this identity. This kind of practice, this is simply I'm talking about trig functions, right? Similar, concept can be applied for algebraic function as well. Okay, so for the algebraic functions, you should know how to simplify two algebraic functions. For instance, 1 over x minus 2 plus 1 over, say, x minus 2 whole thing squared. How do you simplify these two?
Cross multiply.
LCM. You need to find the LCM, right? So these are the basic things you have to have, good understanding about these things. So in this course, we are not studying how to add these two, because you should know how to add these two fractions, right? By using LCM and all. So if you have good foundation in these kind of things, so this will be super easy. Then moreover, you might have studied under trigonometry, solving trigonometry functions. Suppose if I'm asking, hey, if cosine x is, say, 0, your x is now coming from the interval, say 0 to 2 pi. Okay, what are the possible x you may have? Do you remember you learned this in trigonometry or in pre-calc, solving trigonometry equations? So you are given that cosine of angle x is 0. I'm asking what are the possible angles you may have? Your x should come from 0 to 2 pi. You see? So this kind of things is kind of, you need to find out somewhere. So tell me, what are the possible x values for cosine x0 would be?
Pi half.
Remember, x is an angle. You have to tell me in radian.
Pi over 2.
Pi over 2. Cosine pi over 2 is 0. Anything else? Remember, I'm asking you to find x in this, range. That means I'm asking you from 0 to 2 pi all the way. So you have to
3
tell me
pi. 3 pi over 2.
3 pi over 2. Anything else? Basically, cosine will be 0 at this point and at this point as well, right?
Yes.
So this is basically angle is pi over 2. This angle, you have to always measure from 0 axis, right? Then this angle is 3 pi over 2. So there are only two possible x values, for this sort of trigonometry equation. So these are the basic things we should know well at this point. That makes sense?
Yes.
So if you are not comfortable about this, please, my strong recommendation is go back and do all your pre-cal trig and algebra, all the things. study everything and make sure that you're understanding all, simplifications and all. Okay. And now, today, we are going over 3.1 and 3.2. Here we are going to look at how to apply, the differentiation techniques to, finding maximum minimum value of any given curve or equation. Okay. Now look at this definition of extrema. Extrema means the extreme point of your, the function could be minimum value or maybe maximum value. So that is called extremum. Extrema is the plural of extreme, right? Extreme points. So look at this definition. So this is not harder to understand. You are given a function f. Function means you could think of with a curve, right? Graph of the function, curve. Suppose if we are given a curve, right? The minimum value of your curve, minimum value means they are talking about the y value, right? Function value means basically, remember our function is y is equal fx. The function value means basically we are talking about the y value of the function. So extrema, minimum maximum is nothing but the y value of the function. In another word, function value, right? C is here my x value, right? So the definition here says that if there is a minimum of the function value, what does mean by that? From the given interval, that means other than that value, remaining all the x values should be bigger than that of fc, right? Because if it is minimum, that is going to be the smallest value, or in that interval. So that is called the minimum. Maximum means what? If fc is maximum, that means that fc should be, greater than or equals to any function value in that interval, right? So that's obvious, right? Minimum means should be smaller, and maximum means should be bigger for any kind of function value in that given interval. Okay. So now look at this picture, for example. You see the given curve is this, right? This guy is the minimum value, right, for the given function in this interval, -1 to 2, right? So if you look at your curve, it's going all the way, increasing the function value. That means increasing the y value. The maximum y value is 5. That is my maximum function value in this interval, -1 to 2. So remember, if you have, square brackets, that means we have to include the endpoints, right? So you have to include the endpoints. Okay. So in another word, we call this interval as closed interval, right? If you see the parentheses, this is called, you have to exclude the endpoints, okay? Right? So this is called the closed interval. So if it is closed interval, you have to include the endpoints. If it is open interval, you have to exclude those endpoints. Okay. So you have to look at the problem carefully. Now here I have square bracket, therefore endpoints are included throughout my domain. Therefore the minimum is 0, right? The x value is 0, minimum value is 1, y value, and the maximum is 5 occurring at x is 2. Look at this picture. Remember, now our interval is open interval. Therefore, we cannot include -1 and 2 in our domain. So you have to look for the smallest and biggest value for the function inside the interval, right? You see now you have to, undefined points because we don't want that, right? We don't include endpoints. So you have to look for the maximum and the minimum value here, right? I see the minimum value of the function here, but do we have any maximum for this curve?
No.
No, we cannot say this is maximum because we did not include that point. Therefore, this picture, does not have a maximum value, but only we have minimum. So maximum and minimum, all extrema values depends on your interval, right? If it is closed, take the endpoints. If it is open, exclude the endpoints. Okay. So now you should be able to understand everything. You see in this picture, this curve, you see there's a hole here, right? That means we do not include this point as our domain. Therefore, we cannot say that function has minimum here because we don't have, function is not defined there, right? So, right? So therefore, this function does not have a minimum, but now we have maximum because the given interval was closed interval. Okay. So the interval may be given in bracket or parenthesis form or by using the inequality. Look at this. For this example, before going to do that, look at this theorem, extreme value theorem. What does it mean by extreme value theorem? If function is continuous on a closed interval, right, then f has both a minimum and maximum. If you could draw a continuous function, for example, if you could draw a continuous function, right, within that, the closed interval, then function definitely will have maximum and minimum value. Yes, that is obvious, right? If you could draw a continuous function, function is defined everywhere inside and the endpoints as well. So function is defined, and for sure you will find one minimum and a maximum since my interval is closed interval. That's what this theorem says, right? So that is extreme value theorem. But look at this with the first example. You know, the given function is now x squared parabola, right? So parabola has this parabola has like this shape, y is x squared curve. It has minimum, right? We know that. So this function has minimum. If you could drop these pictures and check. The function has minimum value at 0, but no maximum value because we do not include the endpoints, right? Your x should be less than 2. You don't see here equal sign. Therefore, this is nothing but open interval. In another word, you could write this inequality as open interval -1 and 2. That's the meaning. So there's no, maximum. But this is closed interval. You are including endpoints -1 and 2. In another word, you could write like that. Sorry, like this. So definitely you will find maximum and minimum value because of extreme value theorem. Again, here we don't include 0 and 2. Draw this picture and check, do you see any maximum and minimum in this interval? You don't see, because remember we had the minimum at 0, but now you don't include 0, therefore you don't find any minimum, maximum either, right? So you cannot find anything else. So you just draw the picture and check. Okay. So again, this also the same scenario, right? Because you do not include 0, therefore no minimum, but you include 2, so therefore there's a maximum. Okay. So this is all about the extreme value, right? Maybe maximum, maybe minimum. Do you have any question at this point? There's no question. Let's move ahead. Okay, now this is called the relative extreme. Earlier we had extreme, right? Now this is relative extreme. What does mean by relative extreme? If there's an open interval containing C, now we are always, assuming that the given interval is open interval. Okay, so you are given an open interval, right? Inside the open interval, there's a point C, right? If there's an open interval with the point C inside the interval, right? Then if you find one maximum value inside, okay, that maximum value FC is called, remember why this is maximum value? We are looking for Y value, right? Maximum or minimum values means nothing but Y value, function value. So function value is called relative maximum if function has maximum inside the open interval. Okay. So that point for example, if I draw like this picture, say this is the maximum point you will get inside. I need to take the open interval now. Okay. For example, you are drawing a graph like this. Say this is my open interval A and B. You see now, I see the maximum point here. So this is like our C, this point, right? Remember, this is my Y, this is my X. Let me recall function as fx. Okay. Now you see function attains maximum at this point, right? That means this is my function value, fc. This is my corresponding, x value. So therefore, what is the coordinate of this point? Coordinate is nothing but x coordinate is c, y coordinate is f of c, right? So according to my picture, this is going to be my relative maximum. Why it is? Because this is the maximum value inside the open interval I will see, right? Therefore, you have to understand clearly fc is, right, relative maximum, right, occurs at x value c. Then what is the maximum point? Point means you have to always give in coordinate form. This is my maximum point, x value is c, y value is f of c. So you have to understand all three things, right? So that is what it is here in explain. Okay. Similar things you could apply for a relative minimum as well. So you have to look at the minimum function for this and the condition applied like earlier. Okay. That is called a relative minimum. Okay. If you have more than one relative maximum, then we call that as maxima, right? Maxima is the plural of maximum. So minima is the plural of minimum. Okay. So please go through these things. Now you will understand clearly. This is the given picture. F has a relative maximum at 0, 0. Yes, because this is within some open interval, this guy is attaining the maximum, right? Similarly, this guy value having the minimum value within some open interval, therefore this is going to be my relative minimum. Okay. Make sense?
Yes.
Okay, very good.
Yes, sir.
Yes, good. So now you have a lot of definitions throughout this chapter. Next one, the critical number. This is the most important part of our section here, 3.1. What is the definition of the critical number? What does mean by critical number? If you are given a function f, right? If you could find the derivative at some value c is 0, or if the derivative does not exist, that means if f is not differentiable at c, then those kind of c's are called critical numbers, right? So critical numbers basically can occur in two different scenarios. Okay, critical numbers or number, maybe more than one. Okay, numbers or number. So there are two scenarios always. One is you have to look for the point C. You have to find out point C such that, right, the derivative of the function evaluated at that value is 0. In other words, you are finding the value C such that the slope is 0, or f prime at that C may be undefined, does not exist, right? So if you are asked to find the critical points, basically you have to check two things. One is check is there any point, right, which is giving slope 0, or ask yourself is there any point where the derivative is undefined. So those kind of points are called, C values are called the critical numbers. Look at these two pictures, the scenarios, right? Remember, I told you in chapter 2, if if there's a sharp turn or like a sharp edge, right, for the graph, at that point function is not differentiable, right? Remember, recall the function we checked last time. Oops. Do you remember y is equal, do you remember the curve we learned, y is equal absolute x? Do you know how to draw this? How do you draw this picture? We already have discussed. The absolute x function is like a V curve, right? So function is not differentiable at this point. Please look at your note, go back and check your note and differentiability. So function is not differentiable here because you will have two different slope at this point. You cannot have two, two different slope here and there, right? Therefore function is not differentiable. So when you have the sharp edge, so there's no, differentiability there. So this picture has this point is not differentiable. Therefore this is, one of the critical points because f prime c undefined. But here it is very smoothly turning. When you draw a tangent line to this point, you will have always slope 0. Therefore this is another critical point. So horizontal tangent line will have always the critical point at that point, right? So keep in mind, if you are asked to find the critical points, you have to look at two scenarios. One, ask yourself, is there any slope 0 point? Or ask yourself, is there any undefined slope? Okay. Now, this theorem is very, very important theorem. Relative extrema, remember relative extrema? We are looking for the extremum, minimum or maximum value inside the open interval, right? This theorem will give you kind of, easy results. Relative extrema occur only at the critical point. You don't need to check any other point, only check critical point, right? If you are asked to find relative extrema, check only, the critical points. If you have critical points, there you will find the extrema. Maybe minimum, maybe maximum, we don't know. Okay. So if you are asked to find the relative extrema, first to find the critical points, then find the function value at those points. Then you will find the minimum or maximum. Okay. So keep in mind these 4 steps. Guidelines for finding extrema on your closed interval. Remember now, you are finding the extrema on closed interval. What does mean by that? That means endpoints are now included. Right? No confusion. Here they are asking extrema. But relative extrema is different thing. Relative extrema will be always inside the open interval. Extrema may have at the endpoints as well. Okay. So if you are asked to find extrema, that means you have to check everything. Whether you have relative extrema or you have some other minimum maximum. You have to check everything. Okay. So follow those 4 steps. To find extreme values, minimum or maximum value of a given continuous function in closed interval AB, first find the critical numbers in the open interval, right? That means you are finding the critical numbers inside the, this interval. After finding the critical point, find the function value at those critical points. Remember, according to this theorem, you will have relative extrema inside those, at those critical values. After finding those relative extrema, now find the function value at the endpoint, A and B, right? So basically you have to find the function value f at A, function value at B, then you have to find the function value at where? At your critical point. So basically you have to find all these values, f of A, f of B, and f of C. Here C is critical point. You may have more than one point, okay? You may have so many FCs, maybe more than one. So after finding all the values, you have to check which one is the smallest among all the values. That is going to be the minimum, right? Then vice versa. Then if you find anything bigger number, that is going to be the maximum, extrema, means maybe maximum or minimum. So these are the idea, so to find the minimum and the maximum. So we will look at one example. Look at this. Find the extrema of this function on the closed interval, -1 to 2. Okay, remember what is the task? Task is to find minimum or maximum value of the function, right? On that closed interval, -1 and 2. Remember, endpoints are now included. You have to find the function minimum and maximum value. What is the step we have to follow? These 4 steps. First, find the critical value. How do you find the critical value? 2 scenarios. First, find the derivative of the function and check whether is there any point giving 0. Look at here. So the given function is this, and we are finding the derivative first, right? So this is the derivative. After getting derivative, always set the derivative to 0, okay? And solve for x. Ask yourself, is there any possible x values? In this problem, yes, we have 2 critical numbers, 2 x values, okay? 2 critical numbers. Not only that, you have to check this condition also. Ask yourself, is there any point giving where, you know, the derivative does not exist? Remember, this was my derivative function. This is simply a polynomial. This is a very good function, always defined. F prime x is always defined. Therefore, you will not find any point such that which is undefined. Therefore, you don't find any undefined points. That's what they explain here. Okay, so that means what? That means only these are the 2 critical points, right? Okay.
Why did you set the 12x squared to x minus 1?
Say it again.
Why did you set the 12x squared to x minus 1?
Here,
Oh, factor. Okay.
yeah, they are
okay.
factoring. They are factoring. Yes, the simplification and finding x values. Yes.
Yes, sir. Okay.
Now you see, you have these are my x values, right? Critical numbers. So you have to find the function values at these points. That is why we made the table. You have to find the function value at the left-hand point, function value at the right-hand point, function value at those critical points. In total, I have 4 different values. You see that? So one critical value is 0, plugging into function. Remember, my function is here. Plugging 0 here, you will get the function value at 0, which is 0. Now my second critical point is 1. Now plugging 1 into this function, you will get f of 1. That is my function value at that critical point. This is -1. Nothing. You see now, you have to plugging these 2 as well, right? So now check these endpoints. You are plugging -1 to the function. You are getting function value 7, and you are plugging the next 2 endpoints of the function to 16. So basically, I have now 1, 2, 3, 4 numbers. Among those 4 numbers, which one is the highest number? Yes, I see here. The maximum is 16. So this is going to be my maximum extreme value, maximum value of the function. This is going to be our minimum value. That makes sense? Okay.
Yes, sir.
Yes, good. So these are the worked problems I already have, included. So I believe you could go through these and make sure that you understand everything. Okay. So always make the table after finding critical point. Now here under the exercise, I'm going to do some more problems from your textbook. Okay.
Quick question.
Yes.
Sorry about the kind of dumb questions so far. But with this section, is this going to rely heavily on the unit circle, or is this going to be mostly a linear graph kind of?
Both mixed.
Okay.
Both. So I'm going to discuss one trigonometric, yes, unit circle problem as well. Okay. Do you see here any? Yeah, this is unit circle problem. Okay. You see here? Okay. So now.
2 videos or the videos on YouTube. We can just do that and not have to worry
Yes,
about
you can. You are absolutely. You can do that. If you are fine, then no problem. I'm telling you, if you have any trouble in understanding those things, and I strongly suggest you to, make one
Yes, sir.
appointment and we will discuss. Okay.
Yes, sir. I just wanted to clarify that.
Yeah. So Look at this point, this problem, number 9. The problem is find the value of the derivative. So they are asking us to find the derivative function's value at each indicated extremum. So you will be given one extreme points now. You know now, right? Extreme means either minimum or maximum. So look at this number 9. So the extreme point is now here, right? In other words, the minimum value of the function is here. So you are given a point. You need to tell me what is the derivative value, right? At this point, the given function is, gx. So first you need to find, a g prime x. Okay. So I'm just writing here, but anyway, I'm going to include in my worked out class note. You will see after a couple of days in Georgia View. Okay. So from your exercise 3.1, problem number 9. So you are given function gx is x plus 4 over x squared. Okay. So the given graph is like this. This was our extreme point. Okay. 2, 3. The function gx is this. You need to find what? You need to find g prime, right? The derivative value at where? At the x is now 2, right? This is my x. So simply they are asking you to find g prime at 2. Okay, let's who is telling. What is g prime x? Simply I'm asking you, hey, could you differentiate this function? X plus 4 over x squared. Take a piece of paper.
Negative 8 over x to the third.
Say it again.
Negative 8 divided by x to the third.
I just want to check with others. Is that correct? You see now you have here x. You have now two functions. What is the derivative of x?
1.
Did you miss that one? The derivative of x is 1. The derivative of 4 over x squared is the answer you said. Do you see that?
Yes, sir.
Yeah, so please work on that. How do you find the derivative of this? The derivative of 4 over x squared. How do you find that? This could be written as d over dx of, you could simply move, the exponent to the numerator by switching the exponent to negative. So this is 4 times d over dx of x to the power negative 2. So remember the formula we have for the power rule, x to the n, derivative is nothing but nx n minus 1. Now in this case our n is negative 2, so simply plugging negative 2 here. So you will get 4 times negative 2, n is negative 2, so here x negative 2, negative 1. So that is negative 8, x negative 3. So again, take this guy, switch back to the denominator. So it's going to be x cubed. So that is only the derivative of second piece, right? Only this piece. But you have here x, so it is 1. Does that make sense, William?
Yes.
Okay. But what do you want? We want g prime evaluated at 2. Simply plugging 2 here. So that is 2 cube is 8. 8 over 8 is 1. 1 minus 1 is 0. Easy, no? Easy. Super easy. Okay. Right. So I will work one more problem. Let's look at problem number 19. Finding the critical numbers. Find the critical numbers of the functions. I'm going to do 19. We are going to find the critical number of this function, right? What is our domain now? Your domain interval is now t is less than 3. Okay. So let me copy down that problem here. So the given function is now again gt, which is t times square root 4 minus t. Your t should be less than 3, right? Let's see who is telling. could you write down this guy in terms of interval notation using parentheses or brackets? How do you write? Your t is any number should be less than 3. How do you write in interval notation?
Open parentheses, negative infinity 3 close
Exactly.
bracket.
Exactly. Very good. So 3 is not included, so it should be parentheses both sides. Okay.
Yes, sir. Yes, sir.
Yeah, good. Your t should be less than 3 all the way up to negative infinity. So this is basically our given interval A. You could think of this is A, this is B, right? So we are asked to find the critical value there. You know, how do you find the critical value? You need to check 2 scenarios. The first one is you have to look for the value C's where in this interval such that the first case what? Your G prime at that C should be 0. That means, in another word, we are looking for the C values where slope is getting 0. First of all, we should know the derivative, right? G prime. So let's find the derivative of this function. Remember now, you have to use the product rule, right? T times 4 minus T. So use the product rule to take the, no confusion. You already have here G, right? So let me use 2 different letters, otherwise you'll be confused. So say this is U and B. If this is U and this is B, right? The product rule says what? U times B prime plus B times U prime. Okay, U is T. My V is square root 4 minus T. The derivative of square root function is always going to be 1 over 2 square root of everything. Then times, the inside function. I'm using the chain rule. The inside function derivative is this. So this all my V prime plus V times, V is again square root 4 minus V times U prime. U is T. The derivative of T is just 1. Okay. So now let us simplify. So this is T over 2, right? 4 minus T is in denominator. The numerator here, the derivative of 4 is 0 constant, negative T is negative 1. Plus, here you will get simply 4 minus T. Okay. Now this is the catch. Now this is not Cal 1. This is now algebra. How do you combine these two? You have to go for LCM. Here 1, here this much. So the LCM of these two numbers is simply the product of these two. Right? I believe at this point you should know how to combine these two algebraic expressions. Okay. So no confusion. So negative T is here. Right? Remember, if you have 1, simply you have to cross multiply these two, right? Right?
Yes.
Okay, so please go and check your algebraic work. Over the common denominator is 2 times 4 minus T. Simply I'm multiplying this with that and writing here. And the negative T is here. Right, now simplify further. Negative 2, square root, same thing is simply without square root of that over 2 times 4 minus T. That is, now you have to distribute inside. So negative T plus 8 minus 2T over 4 minus T. So this will be 8 minus 3T, right? This is my G prime. Okay, remember, my interval is now negative infinity to 3. Okay. Now, so far I found only the derivative. So to find the critical number, you have to set your derivative to 0, right? And you have to replace T by C, right? So because you are finding the C value. Okay. So if this is the case, take your function, simply replace the letter t by c and set it to 0. This is my g prime t function, simply here replace by c and set it to 0. So this will give you what? 8 minus 3c over 2 square root 4 minus c, that is 0. Okay, now you have to tell me, could you solve this for c? You see now, you are given a fraction in the left-hand side. Answer should be 0. What is the possible value you could take for the numerator?
8 minus 3c equals 0.
Exactly. If you get the 0 answer, that means only possible way is the numerator supposed to be 0, right? Numerator is 8 minus 3c supposed to be 0. And solve this guy for c. So c is nothing but 8 over 3. Am I right?
Yes.
Okay, so this is the only one point we get. Oh, you need to check whether this c is in this interval. Your c should be in this interval. How much? 8 over 3. So 8 over 3 is roughly 2 point something, right? 2 point, is that 66? What is 8 over 3? 2.67, yeah. So it is 2.67, right? So yeah, that is correct. This number is in this interval, right? Therefore, our possible one critical value is 8 over 3. Don't write 2.67. You cannot round up, okay? I just round it up because to check whether this is an interval. But you have to write the exact value, 8 over 3. So I found one critical value by setting what? Slope to 0, right? So for the second scenario, do you find any c value such that g prime c does not exist undefined? Undefined mean what? Denominator should give you 0. Right? Remember, my g prime c is nothing but 8 minus 3c over 2 square root 4 minus c. This is my g prime c, right? This is my g prime t. So g prime c is this. I'm asking you, could you find out one c value where this guy does not exist? For which value c, this will be undefined. Undefined means the denominator should be 0, right?
If c is equal to 4,
Exactly. If c is 4, you will get the denominator 0. Numerator should be good number. Yes, I am getting good number. Make sure that you are not getting 0 over 0. Right? You cannot get 0 over 0. For undefined point, you have to have denominator 0, right? But the numerator should be a good number. Okay. Yes, c is another value. Now the thing is, can I assume this is another critical value?
no.
No. Why? Reason is
It's outside the interval.
it is outside the interval. Very good. You cannot take now this guy because I am looking for the z values should be in this range. Therefore, even though you are getting one, undefined point, this is not in my interval. Therefore, I am not interested in this. Therefore, only one critical value we found, which is right. Therefore, the critical number is nothing but 8 over 3. That makes sense now? Now, I believe everyone should understand finding critical values.
So how many critical values are you supposed to find per?
You have to find everything in that interval. All the points supposed to be, determined. You see now, I'm going to work one trig function problem. Okay. Problem number 22 from your textbook. You need to find all the critical values for this function. Remember now, theta is going to be an angle in radian. Remember my interval is now 0 to 2 pi, right? Open interval because you don't see here equal sign. Okay. So let me copy down this problem here. So we are going to work problem number 22 from 3.1. The given function now in theta, which is 2 secant theta plus tangent theta. Our tangent value, theta value is supposed to be 0 to 2 pi. In interval notation, this is nothing but open interval 0 to pi. Right? So first of all, you need to find as usual the derivative of the function. So let us find first the derivative of f. Let's see who is telling. What is the derivative of secant theta?
Secant tan.
2 times secant theta times tangent theta. Please take the printout of the formula sheet. I have,
Tangent.
yeah, take that formula sheet and always keep with you, okay? So you have to get practice. So now, what is the derivative of tangent?
Secant squared. Theta.
Yes, you are correct. So now this is my derivative. Again, you need to find out two things. So before that, you see now, this is the catch. You are going to use the trig knowledge to simplify this. Okay. So what I'm going to do is, I'm going to factor this. Remember, I have secant theta here and there. So I'm pulling secant theta out. And remaining is 2 times tangent theta here. Plus here I have square. 1 is already taken out. So you will have one more secant theta inside. Okay. This is my f prime theta. First, I'm going to set this derivative to 0 and I'm checking whether is there any theta value, right? So I'm going to change theta into C because we use C for the critical value, right? So I'm simply changing that. So I'm taking f prime theta function, simply switching theta to C and set it to 0. So you will get what? You will get secant C to tangent of C plus secant of C equals 0. So now I'm going to simplify. Secant of C, let me rewrite tangent in terms of sine and cosine. Remember, tangent is sine over cosine, plus secant is the reciprocal of cosine. You see now, you have same denominator, therefore LCM is that guy. So simply you could add the numerator inside over LCM is cosine of C, 0, right? So now remember, this could be written as, this fraction could be written as 1 over cosine C times 2 sine C plus 1, right? Now again, 1 over cosine is secant. Here you have already one secant, therefore it is going to be secant squared. That makes sense? So far so good. Now you are going to solve for C. Remember, secant function never gets 0. This is always positive. If you want, you could check the secant graph. Secant graph is always above or below, x-axis. It's never touch x-axis. Therefore, you cannot find, C such that secant is 0. So this is not possible. So only possibility, you are multiplying two numbers, answer supposed to be 0. Only possibility is this guy is supposed to be 0. Remember, what was our interval? Our interval, your C should be in which interval? Remember the interval given in the problem, 0 to 2 pi. Okay, so now solve this equation for sine C. Sine C is nothing but move this plus 1 to the right side, -1, divide by 2. Okay. Now here's the catch. Use the unit circle. You are finding the sign of the value supposed to be -½ What are the possible C? Use the unit circle because your C is supposed to be from 0 to 2 pi. Okay. So you have to use the unit circle. You need to have now sine answer is negative, right? Right. So sine will give you negative answer in which quadrant? Quadrant number?
3 and 4.
3 and 4, sine is always negative. Okay. So again, go for the trigonometry and pre-cal. How do you find, we all know that the sine of which angle is half? Sine of 30 degrees half, right? Right. So one answer supposed to be -½ Therefore, that should be in, remember the reference angles and all you learned in pre-cal and trigonometry. So now your reference angle is pi over 6 because I see half here. right? So this should be pi over 6. Your answer is in now third quadrant. Here to here, angle is pi, but I need one more pi over 6 to find the total angle. This is my C. Okay, so the total angle is now 5 plus pi over 6, which is 7 pi over 6. In another word, sine of 7 pi over 6 will give you negative half. So that is one possible C value. That makes sense? So you need to know the reference angle always if you have a negative or positive number here. So do you find anything else? Do you find any one more?
11 pi over 6.
Exactly. Another one is in fourth quadrant. So now the reference angle mean what? The closest angle to this, to this axis, to x-axis. The closest angle should be the reference angle. The reference angle is now pi over 6. So this should be now pi over 6. Remember, we are looking for the angle from 0 to 2 pi. So you cannot write, I know that this angle is negative pi over 6, right? But you cannot write negative pi over 6 because I don't have negative now in my interval. Therefore, you have to always look for the full circle coming to that reference angle. So here to here, this angle is now pi over 6. Full circle is 2 pi. So you have to subtract pi over 6 to get this whole angle. So the next angle is going to be 2 pi minus pi over 6, which is going to be 6 times 2 is 12. 12 minus 1 is 11 pi over 6. Yes, correct. This is another angle. So please check, sine of 11 pi over 6 is negative half. So I found the two C values. Yes, these two are going to be in my interval 0 to 2 pi because I'm looking for my unit circle. So these are the two critical values, right? I have in that interval. Okay, anything else? Do you find any other point? Remember my f prime C is, my f prime is here, right? Do you find any undefined point? I think I find the undefined points, right? So what was my f prime C? Let me rewrite one more time. My f prime C is, I simplified, right? My f prime C is here. This is my f prime, right? Oh, why I'm putting 0? I'm writing the function, right? So this is my f prime C. What will happen if C is pi over 2? So I'm asking you, is there any undefined points? In another word, is there any C value we have such that the denominator getting 0? What will happen if C is pi over 2? Tell me.
Will be 0 in the denominator.
Exactly. Then what will happen if C is 3 pi over 2?
Same. 0 in the denominator.
So again, these are the 2 points giving where function is undefined, right? Because this guy is getting 0. Does that make sense?
Yeah.
So therefore, how many critical points I got? Remember, these two are again coming from 0 to 2 pi, right? Therefore, the critical numbers now, there are 4 then. 1, 2, 3, 4. There are 4 values now, right? So one is pi over 2, 3 pi over 2, 7 pi over 6, and the last one is 11 pi over 6. Okay, so now the thing is, these 2 points, I have to look at these 2 points. If you're plugging these 2 values into the original function, will you get any real value here? In another word, is function defined at those 2 points?
No.
No, right? Right? Even though this is, does not exist point, but in this case, function is not defined. You have to plug in and check here. Secant pi over 2 is undefined, 1 over cosine 0. Tangent as well, right? Therefore, in this case, if function is not defined, you don't include those. So after getting answer, you check everything is defined. Okay, so those 2 points should be excluded. We don't want that because a function is not defined there. Okay, so you could go back and check your critical points, the definition if you want. Okay, so function should be defined, right? You see, f should be defined at that critical point. Now in our case, after listing all the possible critical numbers, after listing all the critical possible numbers, then you have to check whether function is defined. These 2 points are not included because function is not defined at those 2, so you have to throw those 2 away. So answer is simply these 2. Okay, so these are the steps you need to follow always. Okay, so I believe at this point you might have understood these things, and why don't you go through the remaining all worked problems here? There are plenty. Okay, there are plenty here, so please make sure that you understand all the steps. And if you have any problem, please let me know, okay, in coming meeting. So this all about 3.1. Using what? Let me summarize. First, we had the definition of extreme point, extrema, minima, maxima. After that, we had the extreme value theorem. Then we had the critical points definition. Then we had, how to find the critical points and guidelines. Then we found, how to find, extreme values of on given closed interval. Okay. Now let's move to 3.2. 3.2 is we are going to, find what kind of extreme point, the given one are. So for that, we use kind of, theorems. So let's go through first the Rolle's theorem. Okay, there are 2 important theorem in calculus. So one is, the mean value theorem. Another one you will see later. So the Rolle's theorem. What is about Rolle's theorem? Let f be a continuous function on the closed interval AB, and function should be differentiable in open interval AB. If the function value at the endpoint A and B are endpoint in your interval, right? If you see the same value at the endpoints, okay, if function is continuous and differentiable, and if you see such a condition, right, endpoints are having same y value, then definitely there's a point inside the interval such that slope is 0. Okay, that makes sense, right? You look at this picture. Suppose if you are given 2 endpoints, function having same value means what? If you draw a horizontal line, if you draw a line to these 2, it should be a horizontal line. So function value should be same, right? So if function value getting same at those 2 points, definitely if function is continuous, there should be a turning point. Otherwise, it cannot make equal point, right? Function should turn somewhere inside the interval, right, to get the same y value. That's the meaning, right? So you may have like these points or like these points. There are 2 possibilities, but the theorem says what? We are looking only for what? Only for the differentiable function. Function should be differentiable throughout the interval. Remember, this point is not differentiable because it kind of sharp turn, right? Right? So that means we don't apply Rolle's theorem for this kind of picture. We apply like this for the smooth function. Okay, then only you will get the slope 0. Here you will not get slope 0 because slope does not exist here. That is why you don't have derivative here. Okay, so we are looking for the function like this, very smooth function. Okay, so simply if you want to apply Rolle's theorem, check whether all 3 conditions are satisfied. What are those 3 conditions? Function should be continuous throughout the interval, including the endpoints, and function should be differentiable throughout the open interval, right? And the function value at the endpoint is supposed to be same. If these 3 conditions are satisfied, Then according to Rolle's theorem, we could find one point C inside the interval such that slope is giving 0. Okay. Now here also, I have included several problems, right? So, but anyway, I just want you to look at one problem from our exercise. So 3.2. So what is the problem I want to give? Oh, one more thing. I think I need to explain one more thing before going to the mean value theorem. The second theorem, okay. The mean value theorem says if f is continuous, like a Rolle's theorem condition, right? If f is continuous in a closed interval and differentiable in open interval, then you could find always one point inside the interval such that slope at that point supposed to be equals to the the slope of the secant line. Remember, for example, if you have a picture like this, so this says like suppose if you have a continuous function, say this is my given interval a, say this is my function in this interval. This theorem says if function is continuous and a smooth function having derivative everywhere, then you could find one point somewhere right in this interval such that slope at that point should be equals to the slope of the secant point joining these two, right? Now look at point A is here on the curve, point B curve is here, point is here. So if you join these two, join with those two, sorry, I'm unable to draw a straight line, right? So this is point A, this is point B. No need to be on the x-axis. This point may be anywhere. Okay. So now, if this is the case, then how do you find the slope of the secant line? Slope of this line is nothing but f of B minus f of A over B minus A, right? Slope of this line. How do you find the slope of the line? Simply, I'm using y2 minus y1 over x2 minus x1 formula. So the y1 is now f of A function value, right? y2 is my, this point is, x2, y2. This point is x1, y1. Okay, my y1 is f of A, my y2 is function value at B, f of B. My x2 is x value of the point, which is B. My x1 is point A. So if you're plugging these all values into this slope formula, you will get simply the slope of the secant line, which is f of B minus f of A. The mean value theorem says that you will find the same slope, this answer, somewhere inside the function. That means you could draw a parallel line, right? If two lines has slope same, means what does mean by that? Slope same means those two lines supposed to be parallel lines. In another word, I could draw a parallel lines always somewhere on the curve parallel to this line, like that. So you could find always one point here, C and f of C, such that slope at this point, f prime C, right, is equals to the slope of the secant line. So this is basically just, a theorem, right? That is here. So this is called the mean value theorem. Okay. So you could apply mean value theorem and Rolle's theorem to do, problems in this exercise. Okay. So I will do one problem from your textbook. Again, I'm going to do one problem from your unit circle because most of you are having trouble from, finding values from trigonometric functions So just I want to go through one problem from your textbook, problem number 22. What was the question? Using the Rolle's theorem, determine whether Rolle's theorem can be applied to a given function in the interval a, b. Okay, if you could apply Rolle's theorem, then find the value c such that the slope is getting 0 at that point. Remember the Rolle's theorem. If you want to apply Rolle's theorem, remember you have to check 3 conditions, right? So I'm going to do problem number 22. So for sine 3x, we are going to find is there any point c in this interval such that slope is getting 0. Okay, so let me write down somewhere here. So this is from exercise 3.2, problem number 22. The given function is now sine 3x. We are interested in the interval pi over 2, 7 pi over 6. So you could think of this is A and this is B. First of all, you had to check all 3 conditions, right? Ask yourself, there are 3 conditions before applying Rolle's theorem. You have to make sure that it is satisfied. The first condition is f continuous. Ask yourself, sorry. Second question you have to ask is f differentiable? Where? On the open interval. Third question you have to ask, are those 2 values at the endpoints equal? So in our case, our a is now pi over 2 and b is 7 pi over 6. Function value evaluated at pi over 2, we have to check whether it is equals to function value evaluated at 7 pi over 6. If all 3 conditions are satisfied, then only you could apply what? Rolle's theorem. Okay, so you have to check now one by one. Okay, the first question is sine 3x continuous? Remember, sine function is always continuous like this, right? Wave function. So it is continuous everywhere. Therefore, this is satisfied. Okay, so then next one is, remember, what is the derivative of sine function here? The derivative of given function is simply the derivative of sine 3x, which is 3 times cosine 3x.
3 cosine 3x.
Yes, 3 cosine 3x. Remember, this guy also very good function, smooth function, right? Cosine function also like sine wave function. Therefore, the derivative function cosine x also very good function, everywhere defined. Therefore, the derivative is always defined everywhere throughout the real line. Therefore, function is differentiable. Only thing is you have to check the endpoints now. Could you check f of pi over 2? Ask yourself, is it equals to f of 7 pi over 6? So we will check that, right? So remember my function fx is the given original function sine 3x. So I'm going to check my left-hand point function value, that is simply plugging pi over 2 here, which is sine 3 pi over 2. What is sine 3 pi over 2? Yes, William, it is in third quadrant, right?
Yes.
Which is -1.
Yeah,
Right?
-1. Yeah.
Good. So now check the another endpoint, f of 7 pi over 6. Simply plugging now 7 pi over 6. What is that? So 3, 6 gone, you will get 2 here, which is sine 7 pi over 2. Again, it should give you -1. Use the calculator and check. Again, it is going to be in third quadrant, right?
Yes.
Yes. Therefore, both endpoints are giving same value. So this also satisfied. Function value at pi over 2 is equals to function value of 7 pi over 6, which is -1. Therefore, all 3 conditions are satisfied. I could use now Rolle's theorem. Rolle's theorem says what? If you have all 3 conditions, there exists a point, a number. You may have more than one, okay? There, at least you should have one number. C in where? In the open interval pi over 2 to 7 pi over 6, such that the derivative at that point is 0. In other words, there's a slope 0 point inside the interval. So now the thing is, if this is the case, you need to find that point, right? So for that reason, we need to know the derivative of the function. Just now, I just told you the derivative of the function is 3 cosine 3x. 3 cosine 3x is now c. Set it to 0 and check is there any c value. Remember, your c is in that given open interval. Okay, so now your task is to solve this the trigonometry equation. So you could divide by 3 both sides. So cosine 3c supposed to be 0, right? Where c in pi over 2 comma 7 pi over 6. My task is to find now c values. Okay, remember cosine x is always 0 when x is the odd multiple of pi over 2. Your n could be any odd number, maybe negative as well. If you're plugging this 1, 3, 5 positive and negative into this n pi over 2, always cosine of odd multiple of pi over 2 is 0. Am I right?
Yes.
Okay,
Yes.
right. Now, remember, if we apply that here, right, in place of x, now I have 3c. So your 3c is supposed to be always odd multiple. Here your n is supposed to be plus 1, plus or minus 1, plus or minus 3, and so on, right? But we don't think about now negative number because the interval is all positive values. Therefore, you have to look for the positive odd multiple, okay? So I'm starting with 1. What will happen if n is 1? If n is 1, plugging 1 here will give you 3c is pi over 2, right?
Yes.
Then what is my c? Divide by 3 both sides. So it should be pi over
Yeah.
6.
Yeah.
Right? Okay. This is one answer. What will happen if n is 3? Take the second odd multiple. That means simplify here, put 3. That is 3c should be 3 pi over 2, right?
Yeah.
Then what is then c? 3 cancel. Pi over 2. Right?
Yeah. Yeah.
Okay, go ahead. And the third one. What will happen if n is 5? 3c should be 5 pi over 2, right? Right?
Yeah.
Okay, so let me check one more. What is next one? Next odd multiple. 7, right? That is 3z is equal 7 pi over 2. So c is 7 pi over 6. Am I right?
Yes.
Okay, that's enough because we are interested in this interval pi over 2 to 7 pi over 6. So 7 pi over 6 is here, pi over 2 is here. We are looking for the answer between these two. So among these answers, which one is between these two values? Of course, this guy, right?
Yes.
So if you want, you could use the calculator and check. So we are interested in, our C should be in what? C should be in open interval. Remember, we don't include the endpoints. We don't include the endpoints. These two are the endpoints of the interval. So we don't include. Only possible thing is pi over 6 and 5 pi over 6. Again, pi over 6 is not in my interval. My interval is always pi over 2 to 7 pi over 6. So pi over 2 is here, pi over 6 is outside of the interval, so we don't want that also. So only possible critical value in that interval is pi over 6. A lot of work, right?
Yeah.
Yeah. So therefore, the possible critical value is 5 pi over 6. Make sense, William?
Yeah. All of this is going to be recorded, right?
Yeah, I'm
So
going
I
to
can
post it.
follow.
Yes, I'm
Later.
going to edit and post within a couple of days, and you will see there.
Okay.
Right. So you have plenty of problems here already worked out. So I will include some more problems here, and let us go one more problem, then we will stop today. Okay.
Right.
So now I need to use the mean value theorem. So which problem? Okay. Again, I'm taking one trig function problem because I need to discuss more. So problem number 50. Let me check problem number 50. Now we are going to use the mean value theorem. Using the mean value theorem. Okay. So basically, we are finding, the point where you get the same slope, right, with the endpoint slope. Okay. So I just want to check, finding the point C. How do you find the point C? This is the correct. Yeah, this is the correct. So here the problem says that use the graphing utility, and you could check by using the graphing utility whether we got correct answer. But what I'm focusing here is finding such a C value, right? Remember the mean value. So the mean value theorem says what? Again, there are two conditions satisfied to if you want to use the mean value theorem. First of all, function should be continuous on that closed interval, and function should be differentiable on open interval, right? Then always you could find one point C in the open interval such that the slope of the derivative functions is equals to the slope of the second line between B and A, right? So our task is to find such a point C. So go back to the problem. So problem number, I'm writing here somewhere. Okay. So the problem number 50 says the given function is now x minus 2 sine x. The given interval is now negative pi to pi. This is my endpoint A and B, right? So if you want to apply mean value theorem, make sure that two conditions are satisfied. Ask yourself, is f continuous on the closed interval?
Yes.
Yes, because it is a combination of sine and algebraic.
The
Algebraic
known trig function.
Yeah, trig function, and you are adding with algebraic function, or in another word, polynomial function, always continuous, right?
Yes.
Therefore, this is also going to be continuous. Yes. Again, for polynomial and sine cosine function, it is very smooth everywhere. Therefore, the derivative is exist everywhere. So if you ask this question, is f differentiable on open interval? Again, answer is yes. Okay, why it is yes? Because if you look at the derivative, is simply the derivative of x is 1, the derivative of sine x is cosine x. If you try to draw this function, you see this function exists everywhere, defined everywhere, in another word. Therefore, this guy is defined as well. So the derivative is defined as well means what? It is differentiable. Okay. So now two conditions are satisfied. So what is our task? Our task is to find. Therefore, by mean value theorem, we use the short form MVT. By MVT, we could find there exists at least one C, right?
Yes.
Yeah, there exists a value C in the given interval such that the derivative evaluated at that point C should be equals to f of b minus f of a over b minus a. In our case, a and b are simply these two values. So if you're plugging those, f of b is pi, subtract f of a is negative pi over pi minus negative pi, right? I'm simply plugging the values. So could you simplify this? Okay, so I need to find out now f of pi and f of negative pi. So what is f of pi? Simply plugging pi into my given function. Remember our original function is x minus 2 sine x. So if you're plugging pi over there, you will get what? You will get f of pi is pi minus 2 sine pi. Simply I am plugging pi. So that is pi, sine pi is always 0. So that is simply pi. So if you look at f of negative pi, again you are plugging negative pi in place of x. Again sine negative pi also 0, so you will get negative pi. So if you're plugging these two here in this formula, f of pi is pi minus f of negative pi is negative pi over minus into minus plus, the denominator will be 2 pi. So if you simplify further, negative, negative, positive, you will get 2 pi over 2 pi, right?
Yes.
That is 1, right? That means what? That means by mean value theorem, you could find one point C such that the slope of the, that function at C is simply 1, right? What is our task? Our task is to
Would that
find
be the slope of the tangent line also?
exactly, that's the meaning. Slope of the tangent line where? At the given point C now, right?
Yeah.
Yes. So now use the derivative function. Remember, the derivative of the given function is just now I wrote somewhere. 1 minus 2
1 minus
cosine
2
x.
cosine x.
Yeah, 1 minus 2 cosine x. Okay, but I am looking for the point where f prime c equals 1. That will give you simply plugging c. X is now c. 1 minus 2 cosine of c should give you 1. So our task is to find such a c. So you have to solve this equation for cosine c. Easy. Gone. 1, 1 gone. So negative 2 times cosine of c is 0. That means dividing by negative 2 both sides. Simply cosine c should be 0. Okay, where is our interval? C is in which interval? The interval is negative pi to pi. Now your task is to find such a C from negative pi to pi. Remember, as I told earlier, your C is supposed to be odd multiple, right? To get the 0 answer of cosine. So your n should be plus or minus 1, plus or minus 3, and so on. Okay, now you need to include negative as well because your interval has negative. Okay, so let's check one by one then. So if n is negative 1, plugging here negative 1, what is your possible C? C is simply negative pi over 2. If n is 1, then plugging 1 here, you will get C is n pi over 2. Then if n is negative 3, what is my possible C? Negative 3 pi over 2. If n is 3, then my C is positive 3 pi over 2. If n is negative 5, then C is negative 5 pi over 2. I don't want here after y because this is now exceeding my interval, right? Do you see that?
Yeah.
Yeah, this is not in our interval. This also not in our interval. So we don't need to compare these things. Do you see that? My interval is negative pi to pi, right?
Negative.
So we
Yeah.
got two answers now in our interval. Am I right?
Yes.
So these are the 2 points where, the mean value theorem satisfied. That makes sense?
Yeah.
Yeah.
Will you have this over the weekend
Yes.
on the record?
Yes.
The,
I'm going to, I need to edit this, and I will edit maybe tomorrow, and I will be able to post by tomorrow, maybe evening.
Okay.
Yeah, you have lots
Yeah,
of,
that's good. I'm just going to have to go, step by step.
exactly. That's what, I'm going a little bit faster because if there's a video, you could always rewind and check. Playback.
That's right.
Yeah.
Right.
So I want to cover as much as, possible problems because I included so many in my class note, and again, I'm doing different problems, so you will get better understanding, right?
Yes.
So the more you work, the more you get. Okay.
Right.
So my suggestion.
You,
Yes,
when
sir.
will you grade the test?
I still did not start because weekends only I'm going
Well,
to.
yeah.
I will
There's
be.
no need. There's no hurry.
Basically, I told you, right? I need 1 week to finish my grading. I have a lot of work. So, so
Right.
yeah, I'm giving this, message to everyone because I'm going to upload this video. You see, those who are not here, you have lots of things to cover, right?
Yeah. And it's a lot more to
Exactly. That is what this calculus one
lot more to
says.
come too. To get
Exactly.
behind.
Right. So,
Yeah. You shouldn't get behind, fall behind, because it
right.
bills.
You cannot have backlog, then you will be in trouble, right? So
That's right. That's right.
make sure finishing everything on time. And if you have any trouble in your design, come to this meeting and post your problem here. We will discuss. You have enough time now, right? I have given
Yeah.
all the office hours and the meeting 2 hours. You have plenty of time. So let me tell one thing. Your responsibility is to, maintain everything, right? So if you are not doing on time, then you'll be in trouble, of course.
Oh yeah.
Exactly. Okay, so